Pygame is a Python library for building games. It handles your window, your graphics, your input, your sound, and everything you need to go from a blank file to something that you can play. And it is simpler than you think. In this video, we're building a platformer from scratch, no prior game development experience needed, just basic Python. Okay, so the first thing that we're going to do is we're going to set up our IDE to work with Pygame. Now you can set up your IDE in IntelliJ using PyCharm, or you can use VS Code. It'll be exactly the same. What I want you to do right now is create a brand new project folder. So IntelliJ, just create a new project right here, an empty project. And if you're on VS Code, just open up any random folder and then name it Pygame, whatever you want. Then I want you to open up your terminal. Now, opening up your terminal should be the same for even if you're in IntelliJ or VS Code. Just open up your terminal and type in some code. Currently, the first thing I want you to check is Python dash dash version, which checks your current Python version. Now, if you're running a Python version that's greater than 3.13, which is more likely, Pygame off the bat won't work for you because Pygame relies on libraries that work in Python version 3.13 and they don't really work on the latest version. So an alternative for that is we're simply just going to install pip install pygame-ce. Now this C stands for Community Edition and it's a much more latest version of Pygame with more support, bug fixes, and core optimizations. And after you've installed Pygame CE, everything else should work off the bat. If you're running a version of Python that's older than 3.14, so 3.13 or 3.12, then you can directly just work with Pygame itself. Okay, before we get started, I want to talk through how Pygame works at a conceptual level. I'm going to do this by typing a concept file. So I'll create a new file and I'll just name it concepts. And in this file, I'll be showing you how Pygame actually works. So this is the fundamentals of Pygame. The first thing that you need to understand is the game loop itself. Game loop. So every game runs in a continuous loop where thousands of times per second usually. So every piece of code or every code that is inside the main game loop is going to run thousands of times continuously. And every one of these loop iterations is called a frame. And you've noticed if you play games, you have something called frame rate. And usually you either have 60, 144, 180, 200, like a standard frame rate that comes with VSync. If you're familiar with gaming, then you'll know these terms. So we want to control how many frames per second is being updated on the screen as well. Because if you have too high of a frame rate, you don't want your game to run faster. This would make it so that games would work differently on older systems and newer systems. So this is something that we fix in code itself. So each frame does three things in order. So each frame has to follow these three things. The first thing is process input. So anything like your keyboard, like your mouse, or like quit events if you're pressing the cross button on the screen or anything. So that's your process input. Each frame has to process these. Second, it has to update state. Now, state is a special keyword. State is anything, any object on your screen has a state. State is basically a property that something has. Now, it might be moving the player. So you're changing the player state. You're checking for collisions, which is also a collision state, etc. So you do all of these things inside the game loop. The third thing is you draw to screen. Well, after you've checked for collision or after you check that a player is pressing left or a player is pressing right, you actually have to update something on the screen. So you might have to clear the screen. You might have to draw the player again. So draw the player in a new location. You might have to flip the display or something like that. Like if you end the game, if it's game over, then you have to clear the screen and then show the game over screen. So that's drawing to the screen. So in each frame of the game loop, you need to do these three things. And we'll do this in order, highly in order. So all of these things happen. They start. They start the moment game starts and they end when you quit the game. So from the beginning to the very end, this game loop is going to run multiple times every second, constantly checking for these three things. So that is the core idea of how games are made. Every single game that you've ever played, from either Pac-Man, Minecraft, Valorant, everything runs like this. It's basically a loop. Modern games target 60 frames a second. We will also target 60 frames, so this game is only going to be running at 60 frames per second. And these three checks, or these three steps, they never change. So I'm going to first of all start by creating like a bare skeleton of a Pygame, how it looks like. The first thing you do obviously is import the module. So you import Pygame at the very top and you need to initialize it. So you simply just Pygame init. Then Pygame gives you a bunch of things that you can work with, and one of those main things that we constantly work with is the screen itself. It is the window that pops up when you initialize Pygame. So you can control this by giving it a variable, screen equals to pygame.display, and you can set the mode. So if you just want to display, that's fine. I want to set the mode, and set mode basically is a fancy term for saying the size of the screen. So it takes a tuple. I'm sure you're familiar with this data set. It's a tuple and it takes 800 by 600 is what I want my screen to be right now. The next thing that we're going to do is actually limit these frames per second. So every second, I want my game to be running at a constant frame rate, and that is controlled by a clock. So we create a clock, pygame.time.clock, and we can use this clock to limit how many times our game loop is going to run every single second. So by default, our game loop is running true. So our game should be running, and we start a forever loop. I mean, infinite loop somewhat, because currently running is true. So as long as it is true, this loop is going to run. So this is actually our main game loop. That's all. We're using the clock to cap the frame rate. So you can call it vsync as well. Vsync caps the frame rate to your refresh rate, but we're just capping the frame rate to 60 in our case. So number one, events. We talked about events, right? And number one, processing input. So those are events. So what you want to do is for event in pygame.event.get. So Pygame has a library of events that stores inside pygame.event.get. So it might be mouse up, mouse down, everything is stored in here. And you can look at that event, so you can loop through each one of those events and check it. So if event.type equals to pygame.quit. So pygame.quit is an event. It is an event in here. And since we're looping through all of those events, if our event type matches the quit event, so that means if the player has clicked on the quit, we're checking it constantly, we simply just set running equals to false. Pretty simple, right? Since when running was true, this main game loop would be running. Once we set running to false, we immediately exit out of our main game loop. So it just ends our game. So the second thing that we do is update. Currently, we're not really updating anything, so we'll just leave it empty for now. Empty for now, since we're not really updating anything. The third thing is we draw on the screen. So we want to, first of all, run events, then we want to update, and then we want to draw on the screen. So you can do a bunch of things to draw stuff on the screen. For now, let's just screen.fill, and I want to fill it with a color. So this would just correspond to a dark gray background. So notice that this should be 30, and it gives me a spelling error. So notice that this is also a tuple. So most of the things that you don't want to change, you input it in tuple. And then we want to do pygame.display.flip. So basically just pushing things onto the screen. So push to the screen. And finally, clock.tick 60. So it's going to wait 60. So every single second, it's going to make sure that this loop runs only 60 times. So this caps at 60 FPS. If you want higher frame rate, then you can change this accordingly. And we're going to run our file. So simply to run our file, You can either hit run on the top, but I won't do that. I'll go in here so that my VS Code fellows can follow along. And I'm simply just going to type py and then the name of the file. So concepts.py, and I'm going to press enter. And we see our Pygame window. See, we're almost there yet. We have a background, which is gray in color. We haven't changed the title or anything, but one thing that we did add was if we press the quit button, then this piece of code should run. So if you press the quit button, it says running to false and that exits. You'll notice that if I comment this out and then run the file, that this quit button doesn't actually work. Your game is actually frozen and this window is frozen. So you actually have to manually end this by exiting it here. So make sure that you add this to your code so that you're looking for that event, which is the cross button. All right, now let's dial it back. I'll continue in the concepts itself, but one by one, we'll be going through every building block that makes Pygame Pygame. So we have our main game loop here. I'll explain this one more time before moving on. We imported our Pygame, then we initialized our Pygame module. Then we set our screen. You can do a bunch of things with the screen, like resize it, set it to full screen and stuff that we'll look at. So at the very beginning, we just did pygame.display, and set mode basically just takes a tuple. Tuple is immutable data, and this is the size of your screen. So 800 by 600 pixels, width and height. Then we make a clock. So we use a clock to limit our frame rate. Frame rate means how many times we want our main game loop to run every second. By default, our game is running. Whenever we want to exit our game, so whenever we want to close the window, we set it to false. Now this is our main game loop. So as we discussed before, our main game loop has to do three things. One, it has to process input, it has to update the state of our objects on our screen, and it has to draw those things to the screen. So in our main game loop, the first thing that it's doing is it's checking for something. So it's checking through every event. So pygame.event.get will give us a list of events that Pygame has. So it might be moving your mouse, pressing a key, whatever, every time. You'll use the syntax every time, so you'll get used to it. And we're pulling that into a variable called event. We're checking if that event type equals to pygame.quit. So pygame.quit is an event where you either do Alt F4 or press the cross button or exit from your window or anything like that. It detects it and calls it pygame.quit. So if you've done either of those things, then it's going to set this running variable to false. When it does that, this while condition becomes false and we exit our loop. The second thing we're doing in our loop is updating. Right now we have nothing on the screen to update, so we just left it empty. And the third thing is we're drawing on the screen. For now, we're just filling the screen with a dark gray background. We have to do pygame.display.flip to update our changes. So we're pushing our updates to the screen. And clock.tick60 basically means it's limiting this game loop from running too many times every second. It's going to make sure that it runs only 60 times every second and not more than that. Okay, now let's move on to PyGameRect. So PyGameRect is something that you'll be using constantly throughout this video. So it's basically drawing a rectangle on that screen. Simple as that. So everything on your screen is a rectangle. So the player that you saw at the beginning is also just a rectangle. So you can call it PlayerRect, which is your player rectangle, and call this method called pygame.rect. This will draw a rectangle on your screen. Will not draw, but it defines a rectangle that you can draw on your screen. We can first of all set the width, then we can set the height. We can first of all set the x coordinate, we can set the y coordinate, and we can set the width, and we can set the height. So if you hover over this method, you can also see that it is a rect class, and it takes in an x coordinate, a y coordinate, a width, and a height. After that, we can pygame.draw.rect. So we can draw this rectangle onto the screen by using pygame.draw.rect. The first thing that you have to pass in is where to draw it. You see, we took our screen at the very top, so we want to draw it on the screen. On the screen, And you want to give in another position. So you want to pass in another argument, and this argument is simply the color. So I'll give it 0, 200, 0. So this is basically a color. And the last, this is RGB value, by the way. And the last is the rectangle that you actually want to draw. So player rect. And if you run this program now, so you can either press run on the top, but I'll just be doing py and then running concepts.py. Okay, so having known all of this, let's move on to more fun stuff. What makes your game a game? Well, you have components inside your game, right? Like your player, your platform, and everything. What do you think they're made out of? They're shapes. They're rectangles, and on top of the rectangles, we just put images. So the first thing that you need to understand is creating shapes in Pygame. So you can draw a bunch of shapes, more like drawing shapes. You can do this via a couple of methods. The first thing that we're going to be looking at is how to draw rectangles. Primarily, your entire game runs on rectangles. Your character is a rectangle, the platforms are a rectangle. Believe it or not, your enemies, your coins, everything are just pieces of rectangle, and you put images on top. So the primary function that we use to draw a rectangle is pygame.rect. And this method takes 3 arguments, what we call it. Arguments are basically things that you pass on to that method. So first you have your surface, then you have your color, and you have the actual rectangle itself. So let's start by defining what surface means. Surface is where to draw this rectangle. So usually you'll just have your screen and you'll draw this rectangle onto your screen. So your surface is just your screen. Second, you have your color. So color is the color of that rectangle. So what color you want it to be. This takes a RGB tuple. So tuple basically means non-changeable data value. So made of 3 numbers. So you can set a rectangle to be red by doing 255, 0, 0. So this would create a red color because first is red, then you have green, then you have blue. So RGB. Next, after color, we have the actual rect. So rect is the actual rectangle that you want to draw on the screen. And we can create a rectangle using pygame.rect, and you have to define x, y, a width, and a height of that rectangle. Now, this might be all a bit too much when starting out, but we will go through step by step how to create a rectangle. All right, first thing you need to do is define your rectangle. So for example, I have a player rect. So a player rectangle, my player. Then I can create that rectangle using pygame.rect like I defined right here. And I need a x, a y, a width could be something like 32, and height could be 48. So you have to understand what this x and y means. If you look at our game screen right here, on the very top left, the value of x and value of y are 0 and 0. As you move right, the value of your x starts to increase. As you move down, the value of your y starts to increase. So you must understand this Cartesian plane or this coordinate system. Generally, your normal understanding would be that y decreases when you go down, but in Pygame, it's the opposite. Y increases as you go down. So top left, you have 0, 0, x is 0, y is 0. If you want to move something to the right, you increase its x. If you want to move something down, you increase its y. Consequently, you can understand that the bottom right will have the highest value of x and the highest value of y. Also, when you draw rectangles, we look at the top left corner of the rectangle, and we'll see what that means right now. So on x 100 and y 200, so I want to go right by 100, and then I want to go down by 200. Then I want to draw a rectangle with the width of 32 and the height of 48. Now this just defines the rectangle. This defines the rectangle. It does not have a color yet. It doesn't know that it has to be drawn. We're not drawing it or doing anything to it yet. Where do you think we actually draw this rectangle? Yes, we draw it inside our main game loop. You see, Inside the game loop, the first thing that we do is process input, we update state, and we draw to the screen. So this rectangle that we defined right here, so we define the rectangle here, but drawing it to the screen is actually the job of the game loop. So inside game loop where we're drawing to the screen, so we're filling the screen with a dark gray background and display.flip and clock.tick. So where do you think we would draw? We'll draw right after drawing our background. So first the background loads in, then our rectangle loads in. If we load our rectangle before we load our background, we can't see the rectangle, right? Because we draw the rectangle first and then we draw background on top of it. It's like painting a square and then painting a black color on top of the square. You can't see the square. So our whatever you want on top should go last. And to draw it, we know that we can use this function right here to draw it. The surface that we need is our screen on top. So this is our screen that we want. The color, so let's just say I want it to be green, so 0,255, 0. And the rectangle that you want to draw is player rect. So right here, player underscore rect. And if you run this now, you'll see a green rectangle with the width of 32 and height of 48. You can see that it has moved right by 100 pixels, and then it moved down by 200 pixels. So it's more down than it is right, which makes sense. And where does this 100, 200 actually lie? So you can see the top left part of your rectangle, that is 100, 200. So whenever we move this rectangle, we're moving the top left portion of this rectangle, and we're just moving that around, and the rest of the rectangle is drawn from that point. So if I move it down by 300, this top portion is going to move down by 100 pixels. So just this top portion is going to move down by 100, and then we're going to draw the rest of the rectangle there. So you can see that it moves slightly more down. And if I want to move it slightly more right, then I'll change the value of x, so it goes a bit to the right. And this is basically our player. Currently, it's just a box of green color, but we'll swap this green color with a sprite. A sprite is basically an image, and it will look like our player. All right, before we move on with our coding, I want a small section just to show you what assets we need. Right now, we're just drawing rectangles on the screen, but I want real sprites, real tiles, background music, and everything like that. So I'll just quickly show you where you can get all of these yourself. The ones that I am using will be linked in the source code. So if you go to GitHub, you can see a folder with all of the assets in it. But if you want custom assets for yourself, then these are a few websites that you can check out. So the first thing that you want to check out is itch.io. In itch.io, I want to search for Kenny Platformer Redux. So you can see Kenny Platformer. And if you scroll down a bit, you can see assets for Kenny Platformer. And there's a bunch of assets. So you can see there's ground, there's styles for sky, health, and everything like this. So you can download it by simply just clicking download now. And if it asks you for a donation, well, if you want to donate, then you can donate. But otherwise, you can just click on no thanks, take me to the downloads, and you can download this pack from right here. So Kenny, I want to shout out, is one of the most prolific free game asset creator on the internet. So it creates a lot of assets that people can use, and everything is CC0, so public domain, no attribution is required, it's completely free of cost, but you can give a little kickback and donate to him if you like his work. So simply download this one. While that downloads, so you can go to opengamerart.org. This is another website that I use. And in this website, we can get some background music. This is one of the main archives. So Open Gamer Art. This is one of the main archives that people go to for game music. And you can just search for any like platformer tune, or you can look at 8-bit jump sound and stuff like that. So all of the assets that I use will be given to you, but if you want custom sounds, so you can look at the SFX. So there's multiple sound effects and everything that you can get from this website. Okay, in this section, I just quickly want to show you how I set up my project. So you can ignore these two folders, .id and .venv. These are just folders created by IntelliJ. So what I want you to focus on is not even this concepts file, but this assets folder. So I basically create a folder called assets inside my root folder. And inside it, I have three other folders. So I created these. First folder is images. And inside images, I have a folder called tiles. And inside tiles, I just have all of my tiles. So like my grass blocks and everything. And I have a characters folder where I have my characters and everything. All right. So if you want to do this yourself, I basically just extracted that Kenny assets folder and I just made it so that it works like this. And inside music, all I got was an arcade level 8-bit music. Also, make sure that you're contributing your artist. So I got it from an artist called Wyvern9. So he made this music and I just extracted it. So it's just a background music that I have for my game. And then in sounds, I have a coin sound, so coin collected sound. And I have a jump sound. So these don't have contributing artists, but I got them both from the second link that I showed you in the previous section. Now, if you don't want to set it up by yourself or download these assets, again, one more time, these will be in the GitHub. So you can simply just clone this folder and then get this assets folder and everything will be set up for you exactly how it is and how I'll be doing it throughout this video. So now we'll get started with our actual game. So our game is going to live inside our main file. So main.py is going to be our file, and it is in the root folder. So to get started with our game, first of all, we're going to start with our basic structure. So we're going to import our Pygame. After importing our Pygame, we're going to do pygame.init, and we'll have our screen, which is pygame.display.setMode with 800, 600. So it'll just flash briefly and it will go away because we don't have a game loop right now, but we can see that we do have a screen. Let's also set pygame.display.setCaption. So let's set the caption to be our platformer game. And that's all we'll do for now. So the first thing, I want to display my player, right? So to display our player, generally, before what we did was we created a rectangle and we gave it a color and then called it our player and called it a day. But right now, we're going to use pygame.rect properly. And we actually want to draw the player that we got from our assets. So we have to load our player first. So we have to load the image. And the way we do that is pygame.image.load. So we're loading the image that we got earlier that we downloaded. And at the end, we have to do something called convert alpha. Now, I won't go into details what convert alpha does, but basically it makes it so that your images load properly, your sprites load properly, and the background PNG and everything, it just converts it into the right format that Pygame can use. So make sure that you don't forget this. It'll work without it too, but it might be a bit glitchy, a bit slow. So in this line, all we're doing is we're loading in our player. We're loading in our player sprite. Sprite and image are basically the same thing. I'll use those words interchangeably. So I actually want to go to my folder right here and assets, images, and inside characters, let's look at this. So I want to load this image. So I simply write in the path for that image. So I'm going to start with assets slash inside images slash tiles slash characters. So I have a folder called characters, and I want to get the tile0000.png. So getting this path might be different for you if you're using different assets, but it should be pretty simple since all of your images should be inside assets and images. And inside this, it's pretty easy for you to figure it out, even though like VS Code and IntelliJ will give you the prompt like it did for me. It'll just auto-complete that for you. So we're basically giving in our image path and we're loading it in. So now if we use player image, we can access that image. Second, the image might be of different sizes and we actually don't know how big it is. The width, right now it's 24 by 24. Okay, we can see that, but we want to have a certain size inside our game, right? So we can resize that image. So I want to do that. So player image equals to pygame.transform. We're going to use .transform.scale. So we're changing the size of that image. So we're changing the size of player image that we loaded in right here. So player image, and let's change it to 40 by 60 pixels so that we know how big it is. So it's like 40 wide and 60 height so that we can use it inside our game. And that is pretty simple. So again, player image loads a PNG file from our disk and returns a surface. So this actually returns a surface. Our player image is a surface that we can draw on the screen. And remember that you're not forgetting this at the end, the convert alpha. So convert alpha is very important. It converts the image into a pixel format that Pygame can use. Then pygame.transform.scale resizes this image. So all of these assets that you use are used in various scales. We're resizing our image to be 40 pixels and 60 pixels tall so that you can adjust these numbers to suit whatever game you're making. Okay, right below that, we have our player. So to actually draw the player on the screen, we have to create a rectangle like we did before. Let's say our player X, let's divide this. So at the very beginning, let's create our player rectangle. So player rect, like we did before, pygame.rect, and we can set an X coordinate and a Y coordinate. So we talked about coordinates before, and we can set a height, a width, and a height. So notice that the width and height that I used is same as the image's width and height, because basically on top of this image will load this image. So on top of this rectangle will load this image. So instead of the rectangle, we'll see this image. Notice how we're like hard coding this X coordinate and Y coordinate, and we can't really change the rectangles X and Y if we wanted to. So instead of passing in values directly like this, I'll just pass in player X and player Y. Now these variables aren't defined, so I can define it here. Player X equals to 100 and player Y equals to 400. So that every time we want to change the wherever this rectangle is, we can directly just change this variables and it will change where the rectangle is. That's pretty self-explanatory. Now to actually draw the player. So to draw the player, we do something called BLIT, blit. It is how you put a player onto the screen. So before that, we need our main game loop. So I'll just go ahead and go into my concepts folder, actually concepts file. So I'll open this up and I actually just want to copy our game loop because I don't want to write it again. I'll come here and I will copy our game loop and I'll paste my game loop right here. I think we don't have the running variable, so running will be true by default, and we don't have our clock. So our screen, let's just write screen right here and let's add our clock. So we'll add our clock right on the top. And everything should be running. We don't want to draw anything right now, and background is fine, everything else is fine. So if we run it currently, we'll just see a black, more like a gray background with platformer game on top because we're not drawing anything inside the main game loop. Know that you have to draw something on the screen for it to show. But what we've done in this file is we've loaded our image, we've resized our image, and we created a rectangle. So currently our image and our rectangle aren't related, but we will bind them to each other in a bit. Let's start by drawing our rectangle and binding them with the image. So the way you do that is simply just screen.blit, so blit, and then you pass in your image first, so your image, player image, and then you pass in your rectangle, so player rect. What this does is you draw this surface, so player image is a surface, onto another surface. So player.rect, player_rect is another surface. Your first argument is what, and your second argument is where to draw. So since we use the top left corner, this is going to draw on the top left corner of 100 and 400. So let's run it. So you can see that our player actually appears on screen right here. And our player is like kind of stretched along the y-axis and in the x-axis kind of squished together. So I can change this size value to make sure that it's perfect. So we had 25, 25 originally. So let's see how 25, 25 looks. So change the x, so change the player coordinate in the rectangle itself and change it in the image. And now when we run it, it's a bit small. So let's change it to 40, 40. Let's see how that looks like. And you can change these values around however you desire. So 40, 40, that looks pretty decent. So I think I'll be sticking to that size for now. And you can see that our player is loaded in. So actually this is just a rectangle. And instead of drawing the rectangle with a color, we just put an image on that rectangle. Okay, so far so good. I'll quickly explain through all of the code again. You can skip this part if you understood the code. We import Pygame, we initialize Pygame, we set our screen variable, and we set our title. Then we have a clock that maxes out our frame rate. Then we're simply loading our player into our game. Then we're setting the player's scale. So we're resizing the player to be a bit larger than it actually is. And then we have our physics variables. So velocity x is how much the player is going to move right every frame and how much the player is going to move left every frame. So if it is 1, that means every frame it is going to move right by 1 pixel. So in 1 second, since we're running it 60 frames per second, so every second it's going to move right by 60 pixels. Hopefully that makes sense. If that didn't make sense, then please go back by 5 or 10 seconds and slow down that explanation and make sure you get it. For velocity y, we're going up or down. So if it is 1, then every second we go up by 60. So if it is 1, every second we go down by 60, since increasing value of y means we go down. If it is negative, then we go up by 60 every second. Speed equals to 5, so this is the value that we will use to change our velocity x. Since we increase the speed, our velocity x will be higher. If we decrease the speed, velocity x will be slower. Our jump force is -5, so we will apply this to our velocity y. So every second, if our jump force is -5, our player is moving up by 5 times 60. Gravity is 0.6, so gravity brings the velocity y higher. That means our player moves downwards. Since if the y increases, our player moves downwards. Finally, we have on ground false. So by default, our player is mid-air until and unless we specify that our player is not. Then we have the actual player itself. So player X and player Y is the top left pixel of our player rectangle and where it spawns on the screen. Our player rect is a pygame.rect using that 100 and 400 right here and setting the width and height. Notice that our width and height is the same as the width and height of this image because we load this image onto the player. Then we have our main game loop. While running, we're checking every event. If there's an event that caused the game to quit, then we set running to false and our game quits. Keys equals to pygame.get.pressed, pygame.key.get_pressed. So we're checking to see every single key that is pressed every time. If we are pressing the left key, the left arrow, or we're pressing A, then velocity x is going to decrease by speed. So velocity x is now minus speed if we're pressing that key. If we're pressing right, then velocity x is plus speed. So velocity x is plus 5. So it's going to move to the right. Next, we're checking if we're pressing space or pressing up arrow or we're pressing W key. All of these mean that we want the player to jump. And our player has to be on the ground, since they should not be able to jump mid-air. If all of these conditions are met, then we can jump. We jump by setting the velocity y to jump force. Since our jump force is negative, then that makes our player rectangle move upwards. Next, we can apply gravity. So applying gravity basically means increasing the value of our velocity y by our gravity. Our gravity is 0.6, so velocity y is set to 0.6. Next is the actual moving part. Right now we were just playing around with variables. These variables don't actually move our player rectangle yet. These two lines actually move our player rectangle. So the x coordinate of our player rectangle is going to increase by the x velocity x every single time, every single frame. So if velocity x is 0, then our player rectangle's x coordinate, so our player doesn't move in the x-axis. But we change the velocity x whenever we want the player to move left or right. We change the velocity y every time we want the player to move up and down. Next, we're checking bounds. So if the left side of our player rectangle, so we have left, top, bottom, and right. If the left side of our player rectangle is smaller than 0, that means we're going off the screen to the left. We want to prevent that from happening by just setting it to 0. If we're going too much to the right, then we're preventing that from setting it to the maximum allowed on the right. On the bottom, if we're going off the screen, then we basically set the max value to be right on the edge of the screen. And no longer should we be moving downwards. So velocity y should be 0 so that the player doesn't try to move further down. And we say on ground equals to true because we want the player to be able to jump from the bottom. And that in total results in a game that looks like this. So we can move left and we can move right. But you notice when I press left, I keep moving left, and when I press right, I keep moving right. Now we need to be able to fix that as well, since we want this to eventually decrease. And we can jump like so by pressing the up arrow, space key, or W key. If you want the player to jump higher, well, you can just increase this value, so set it to -15. And when we run this, our player will be able to jump way higher. And if you think the gravity is too less, then you can increase the value of gravity to something like 1.6, so that our player also jumps fast, falls down faster. He jumps higher and also falls down faster. So you can adjust these values based on how you want your game to feel. Okay, now that's out of the way. Right now in our game, our player isn't really looking at different directions. It just keeps looking left, even though when we press right, it's also looking left, and that's not really interactive. So all I want to do is, if our player is facing towards the right, then I want it to look to the right. And if it's facing towards left, I want it to look to the left. And that is pretty simple to do, actually. So above the game loop, right here, we can set a variable called facing right. And by default, let's set it to false, because let's run it. Our player seems to be facing left by default. So let's set it to false. Wherever your player is facing, just set it to that variable. And inside our input section, so right here, we can change that. Let's change it right over here. Let's say changing facing of player. If vel underscore x is smaller than 0, that means our player is actively moving towards left. If our player is moving towards left, then facing right equals to false. Simple as that. If vel x is greater than 0, that means our player is going towards the right, then facing right equals to true. It is as simple as that. Next, inside our draw section, we actually have to update that. So let's update it right after our screen blit. We're going to replace this line. So right now we're just drawing the player image facing left no matter what. But we want to replace this. So if facing right, so if the player is facing right, then screen.blit, player image, player rect. Else, If our player is facing left, then we want to flip this. So flipped equals to, we can flip this image using pygame dot transform dot flip. So we're basically just flipping the image. What do we want to flip? We want to flip the player image, and we want to set true, and we want to set false. So we want to flip in the X direction. So we want to flip it left and right. We don't want to flip it up and down. We don't want to make the sprite upside down. Right after doing that, we want to screen.blit, but instead of player image, we want to blit the flipped image. And that is all. If we play it right now, our player is looking to the right. When I press left, our player looks to the left. Actually, it seems like it is the opposite. So let's cut this and put it over here, and cut this and place it over here. So if facing right, then I want to flip because by default I'm looking left. If I'm not facing right, that means I'm looking left. I just want to draw it as is. So by default, it is looking left. If I press the right arrow, it now looks to the right. You can see the eye of the player is looking towards the right. And if I press left, my player now looks left. You can see the eye of the player is looking left. Okay, so far we have our screen, we have our player, which is a rectangle with the image on top. And we did that by using this function called screen.blit, where we put the player image that we loaded onto our player rectangle. But this time around, I want to add gravity, and I want to add some basic player movement. So what you need to understand about gravity is there's something called a velocity. Velocity is speed and a direction defined. So speed is how fast we want our player to be moving, and direction is, well, where we want our player to be moving. If our player is moving downwards with a constant speed, that is gravity, right? If that doesn't make sense, then let's just look at it physically. So we have our physics variables. I want to define my physics here. So velocity in the x direction, so left or right. By default, we don't want to be moving anywhere, right? Unless the player has clicked on right or left key, we don't want the player to be moving anywhere. So by default, it is 0. Our velocity y is also 0 by default, so we don't want the player to be moving up or down either. Then we can set a speed variable to be 5. So every time the player presses right arrow, we want our x to increase by speed. So whatever speed, if we increase the value of speed, then x will move faster. If we decrease the value of speed, then x will move slower. And we'll implement that logic in a bit. Then you can set a jump force. So jump force is how high you want your player to jump. So this will be a negative value because on the y coordinate, if you want to go up, you have to reduce the value of y, right? So we're reducing it by a certain value to go upwards. So we're going to set it to 5, minus 5. Then we can set our gravity. So gravity, let's say it's 0.6. So we're going to add 0.6 to our velocity y to move it downwards. And every time we press jump, we want to add jump force to velocity y so that it moves upwards. And this will make sense. Last is we want a variable called onGround, and by default it is false. So since we don't want our player to be jumping in the mid-air, so we have to check if they're on ground, and only if they're on ground we want them to jump. So these are some basic physics variables that we use throughout any platform or game, and I'll comment these for you. So horizontal velocity, so player moving left or right. Then we have our vertical velocity, player moving up or down. So by default, they're not moving left, right, or up and down. So this is the speed at which player moves, speed at which player moves. This is the speed at which player jumps, so goes upwards. This is the speed at which player falls. And this is checking if player is on a platform. So if the player is mid-air or on a platform. Next, I want to add some keyboard inputs. So we do that where? We do it inside the game loop. So after events, we can create a variable called keys, and we can set it pygame.key.getPressed. So this is a variable that will hold whatever key we have pressed 60 times every second. So it's going to check for a key press 60 times every second since we use the clock down here. And the key that we're looking at is if keys pygame dot k underscore left. So you'll be using this pattern a lot. So pygame dot k underscore left basically means the left arrow. So if we're pressing left arrow, so all this line is saying if we're pressing left arrow, or keys pygame dot k underscore a. So if we're pressing the left arrow or if you're pressing the A key on our keyboard, we want to do something. We want to set our velocity of our x. So we want to set the x velocity equals to minus speed. Since if we add speed to our x, the value of our x will increase and our player will go to the right. When we're pressing the left key, we want our x to decrease. So we're decreasing by the value of speed. So if we're pressing left arrow or we're pressing the A key, we want the value of our x to decrease by the value of our speed. Next, if keys pygame dot k underscore right, I think you're seeing where I'm going with this, or keys pygame dot, well, d, k underscore d, that means that the player wants to go towards the right. So you have to increase the value of vel x. Vel x equals to, or actually plus, equals to speed. Velocity is now speed. It has to increase by the value of speed. Next, if we're going to use a bracket here, keys pygame dot k underscore space or keys pygame dot k underscore up. So you can press space or you can press up or you can press even W, right? So, or keys pygame dot k underscore W. So if you're pressing any of these keys, so if you're pressing up, space, or W, you want your player to jump. But there needs to be an and on ground. So your player needs to press either of these keys and they need to be on the ground to be able to jump. That makes sense. If all of that is true, then we want to change our vel y. We want to set it to jump force and we want to set on ground to false. Because now that we've jumped, we want to set our on ground value to be false. So let's go over these again. The first thing that we're doing is loading our player image, resizing our player image, then we're creating a rectangle. Inside our game loop, we're drawing the rectangle on the screen with the image on top. Next, we're defining some physics variables. Vel x is the speed at which our player is moving left or right. Vel y is the speed at which our player is moving up or down. Speed is, well, the player of our speed. It is what we use to change these two variables. Jump force is how high our player jumps every second. And gravity is how fast our player is falling. On ground is checking if we're standing on a platform or not. Then inside our game loop, we're getting the keys. So we're checking what we're pressing 60 times every second. If we're pressing left or if we're pressing A, that means we want to move left, we set our vel x to minus speed. So at the speed, negative of the speed because we want to decrease the value of our x. If we're pressing right or we're pressing D, then we want to increase our velocity, so we set it to the value of speed. If we're pressing space or up or W, that means we want our player to jump. And we have to be on the ground, so this prevents us from, jumping mid-air. We want to set our vel y to jump force, so this jump force variable right here. And we want to set on ground to false since we're mid-air now. Next, we want to actually apply the gravity. So we set the values, but those values don't really change our player's position right now. We want to change the player's position. So simply vel y by default, so we're applying gravity here. Applying gravity, vel y by default is going to increase with the value of gravity. So every second, the value of gravity gets added onto our velocity so that every second our player falls faster and faster if they're mid-air. Next, we're actually moving the player. So players underscore x. So player underscore x is this variable right here, which is our rectangle. If we increase this value, then our rectangle moves towards the right. We want to increase this value with our velocity. So vel x, player x is going to, actually we can use player rect.x, is going to increase with vel underscore x. This might be a bit confusing at first, but let's go through it. Our vel x is changed 2 times. So if we're pressing right, then our vel x is negative. If we're pressing left, then our vel x is negative. If we're pressing right, our vel x is positive. We're increasing the value of the rectangle that we're drawing on the screen with the value that is inside vel x. By default, it is 0, so our player doesn't move. But if we press left or right, it is negative or positive. So if it's negative, it moves the player to the left. If it's positive, it moves the player to the right. We do the same thing for our y-coordinate. So plus equals to vel y. The y-coordinate changes 2 times here. So either if we press jump, then the y-coordinate increases by jump force, and by default, it is decreasing by gravity. Is 0.6. Notice that the gravity is positive because increasing y makes it go down. Another thing is we don't want our player to go outside our screen itself. So we have to check if the player is going outside the screen. If we run this currently, our player is just going to fall off the screen. So you have to make sure that it doesn't go out of the bounds of our screen itself. And that is pretty easy to check. We can check if player rect.left is smaller than 0. So player rect.left gets the left side of our player's rectangle. So the left side of our, we can stop the player from moving right now, and we can check. So this part is the left side of our player's rectangle, which has a coordinate, right? So we're checking if the left part is a certain value. So we can uncomment this and uncomment this. So if the player rect left is less than 0, that means if the player has gone too far to the left, then we want to set the player rect dot left equals to 0. So every time our player tries going to the left, it's going to be stuck at the very edge of the screen and cannot go further than the edge of the screen. We have to do the same thing for right. So if player rect dot right is greater than 800. Notice that I used 800 this time because the width of our screen, as you notice on the very top, is 800. So the maximum value on the right is 800. If it's more than 800, well, I just want to reset it, rect.right, to 800. So the right portion of my player rectangle, if it's greater than 800, then I want to set it to 800 so that it cannot go further right. And the same thing for left so that it cannot go further left. Now, I don't want the player to go off the screen on the bottom either, so you can set this yourself. You can try. Basically, player rect.bottom shouldn't exceed the bottom value. So our height is 600, it shouldn't exceed 600. How would you do that? You do it like this. If player rect.bottom is greater or equals to 600, then player rect.bottom should equals to now 600. And we can do something else too. We can set the velocity to be back to 0 so it doesn't try to keep on going to the bottom. And we can also set on ground equals true so that we're telling the game that we're actually touching a floor. Now if you play this, our player should fall, and it should fall to the very bottom. So it falls to the very bottom, and this condition activates. So when this condition activates, we see that the value is greater or equals to 600. It's trying to go further down. So we just set it to be exactly 600. So it's exactly touching the floor and it's not trying to go down anymore, and on ground is true. When on ground is true, if we press W space or up, our player should go up, right? And it goes up by a little bit. It goes up by a little bit, but since we're constantly increasing by our gravity, it comes down eventually. So it goes up by -5, but every single frame it is going down by 0.6. So eventually it cancels out. And we can go left, but we cannot go too much to the left because this condition activates. When we go too much to the left, it checks if the left is trying to exceed the 0, and it sets it exactly to that. And we can go to the right as well, but if we go too much to the right, it will stop us. So effectively, our player right now can go left, it can go right, and he can jump around. But they cannot go outside the bounds of our window. If we start the game right now, all our player does is it moves around, it hits a corner, and that's all it does. It really doesn't do anything. The first thing I want to fix is currently if I'm pressing left, then it keeps going left, and if I press right, it keeps going right. That's what I want to fix. I want it to eventually stop moving left or right. So in my applying gravity, what I can check is right here, if player, actually if val underscore x is greater than 0, val underscore x minus equals to speed. Let's see how that works out. That means if it's greater than 0, eventually it's going to decrease by the value of our speed. That works. I think it works. So, and we'll do the same if it is less than 0. If it is less than 0, then we'll plus equals to by speed. So that means our player can move left and right and they can jump. And if I keep holding it down, then it keeps getting added, because even though we're decreasing by speed, we're also increasing by much higher than that. So our player movement works for now. This is a bit janky, but it just works for now, and we'll leave it at that. The main idea of this portion is to create platforms for our player to be jumping in. Since currently our player is just jumping in, well, nothing, we need platforms for it to be able to jump in. And strap in, because this might be a little bit complicated. So first thing that you need to understand is we have a bunch of images, right? So we have tile 1, tile 2, tile 3. So the first tile is like the left part of our tile, and this is like the middle portion, and this is like the end portion. So if we mix these three, then we'll get, well, a block. First thing we need to do is actually load in those tiles. So right after loading in our player sprite, let's loading in our platform images. So we have 3 images. One is left, middle, and then right. So on the third one, yes, the third one. So we have our left, and then we have our middle, and we have our right. Let's load our start. So let's name it platform start, and let's set it to pygame.image.load. Let's load the start image. So assets, images, tiles, tile 001.png, and we're going to convert alpha. Then we can do the same thing for 2, and instead of start, it can be platform middle. And the same thing for platform end, but instead of 2, we give 3. So we basically loaded these 3 images in. This image, and this image for our tiles. The next thing we're going to do is we're going to scale these. Currently, if we just draw them on the screen, I think they'll be a bit too small because it's 18 by 18 pixels. So let's scale these up a little bit. So platform start, I'm going to scale this by pygame.transform.scale. I'm going to scale platform start by about, let's set it to 32 by 32. Let's see how that looks. And I'm going to do the same for start, middle, and end. So start, middle, and end for our start. middle, and end. So it should be pretty simple so far. We're loading in our platform images, so 1, 2, and 3. And since they're 18 by 18 pixels, we're just resizing them to 32 by 32 pixels. So far, so good. Here comes the more complicated portion of the code, actually drawing these tiles in. So to draw these tiles in, we obviously have to go to the draw section, draw on screen section of our code. So when we're saying the player, if they're looking left, then turn left, and if they're looking turn right, right here we can draw these images. So to draw these images, we can simply just screen.blit. So we can screen.blit, let's say platform start, and let's draw it onto x0, so x0. Let's draw it onto y500. Let's draw it onto x0 and y500. Then we need to screen.blit after start our middle. All right, then we're drawing the middle. The middle is going to be 32 more pixels to the right, and this is going to be 64 pixels, the end. So I hope this all is making sense. It might be a little bit complicated, sure, at the beginning, but just follow along the code for now, and it should all fall in place. So if I start right here, I drew a small platform. Well, let's look at how this platform is loading in. All right, we'll go step by step in all of these, by the way, so that you don't get lost anywhere. I'm going to explain, over-explain might even. And if you feel like I'm explaining a bit too much, then you can skip ahead. So first of all, we need the left portion, the middle portion, and the right portion. We loaded those in, and then we scale them to 32 by 32 pixels. 32 by 32 pixels. Our player is 40 by 40, so you can see the player is slightly larger than these platforms. Next, we're going to actually draw these onto our screen. So where are we drawing it? Well, the first one, we're drawing it at x0, so that's why it's like stuck to the left, and y500. This at the very bottom is y600, and this is y500. So the top left is y500. And you can notice that the bottom left, so this would probably be y500 plus 32. So this is from 500 to 532. It makes sense, right? Because this sprite height is 32 pixels. Then we're going to start the middle. So the middle needs to be obviously a bit to the right. How much to the right? 32 to the right, because this image is 32 by 32. And if we move 32 to the right, then the top left will be x32. Then 32 more to the right, the top left will be x64. Hopefully this is making sense. Every single rectangle, when we position it by the top left. So top left right here would be 0, top left would be 32, top left would be 64. We can actually look at how this would look like. So if we did 32, if we did 64, and after 64 we did 128, you could see that there'll be one tile difference. So you can see there's a one tile difference. Since this top left is, this is a good exercise. This top left is 0, this top left is 64, this top left is 128. And since all of them have the same y value, which is 500, they're all on the same y-axis, but on the x-axis, they're like a bit left and right. So since our tiles are just 32 apart, we know that they should be 32 apart like this, and we can draw a platform. But drawing platform by hand seems a little bit, you would do this for a lot of times and then draw platforms and need to do all these math. So it's a bit complicated. That's why we use something called loops for this. So for this purpose, we'll be using loops. So basically what we defined right here was a tuple. So 0, 500, x, y, right? So we can define these up top and then we can use them right here. So to do that, first of all, I will create a list up here. Now this is going to get a little bit technical, so just please bear with me and follow along. It will be a little bit difficult to get at first, but I will explain it a bunch of times, so don't worry about it. So at the very top, after we load all of our platforms, I want to actually define where the platforms will live right on top. So I'm going to create a list called platforms. And on my game, for example, I want a platform on the bottom here. Maybe I want a few platforms on the top and everything. So I'm going to set those platforms by setting variables right here. So I'm going to set a bunch of tuples. So one platform, so the first platform that I want is on the bottom right here, from all the way to the left to all the way to the right. So I'm going to set 3 variables. First variable is going to be my starting position. I actually want to comment it out. So first is our start, then it is our end, and third is how many tiles. So we're going to start at x equals to 0. So I want to start at x equals to 0. I want to end at the very right. So that will be 600 minus 32, which is 544. Because since we take the top left of the rectangle, the very right, the tile that will be at the very right will have the top left value of the maximum width minus 32. I hope that makes sense. If it doesn't, just follow along. And the number of tiles will be, well, 600 divided by 32, which comes out to around 25. So this will be around 25 tiles. This is one tile. Next, I maybe want another platform. So I'll just draw out another platform. So maybe I want to start at x equals to 192 and end at 448. And I want 9 tiles in that gap. Then, for example, I want 384 and I want to end at 160 and I want 4 tiles in that gap. Now, all these values won't make sense to you right now, but I will make them make sense very shortly. So right here, instead of drawing our rectangles manually, we now loop. Now this is the main portion that people get stuck on and some of you may quit. So please pay close attention to what I'm saying. We're going to loop through this list. We're going to loop through this list, get all of these values and draw our tiles out. So let me copy the format, right? Let me copy the format right here so that I can see what I'm working with. Let's copy it right here. And right above our loop, where we're going to loop, let's write it over here. And let's say looping over the platforms to draw. For, we have 3 variables, start, end, and how many tiles. I'm going to set the start into a variable called x, and to be y, and length to be just length. In platforms, so platforms is our variable, right? It is our main list. So for x, y, and length in platforms, so in the first iteration, we'll get 0, 5, 4, 4, and 25. Second time, we'll get 192, 448, and 9. Third time, we'll get 384, 160, and 4. Now, we could just draw them out randomly, but one special thing that we need to do is the first tile must be this, and the last tile must be this. Everything else, anything in the middle, should be this. So we have to check that condition. To check that condition, we need to loop again. So we need to create a second loop. So for I in range length. So length means how many tiles are there. If I equals to 0, that means if we are on the first tile, if we're drawing the first tile of that platform, then our tile is going to be platform start. We're going to use the start platform. So we're going to use this one if it is the first tile in that platform. Elif I equals to length minus 1. That means if this is the last tile, we're checking if it's the last tile. If it's the last tile, then we want to use this one, right? This one is stored inside tile equals to platform end. Anything else, so anything else means we're like in the middle. So if we're in the middle, we want to use the tile platform middle. Again, I'll explain this. For x, y, length, and platforms, so each one of these tuples, this is one platform, this is another platform, this is another platform, right? So we're looping through every platform. We get the first platform. Now that first platform has a number of tiles, where it starts and where it ends. We're looping through the length. So we're looping through how many tiles there are. If we are on the first tile of that platform, we want to use the starting tile. If we are in the middle, if we're in the end, then we want to use the ending tile. Anything else, we want to use the middle tile. At the very end, we have to actually draw this. So to draw this, simply just screen dot blit we're going to draw the tile. So we're going to draw this tile. And the position where we draw it needs to also automatically be appended in the loop. So we get the x. X is where we start, right? And we add I times 32. Since our width of every tile is 32, if it's the first tile, then I will be 0 and we'll just start at wherever x is. The second tile needs to be placed like 32 pixels to the right of the first tile, because actually this will give an error right now, but if you look at your screen, if you have your first tile here, your second tile should be placed 32 pixels to the right of that. So I times 32. Then we can get our y coordinate. Our y coordinate can just be y, because every platform will be on the same y plane. So we'll just use the y coordinate as is. If we run this program now, we can see that we got 3 different tiles. So for the first platform, let's look at it. We have our first platform. We start at 0. So we start on the top left, 0 right here. And we end at 544, which is right here. The number of tiles that we have in between are 25 tiles. That's this width, 600, divided by 32. And inside the loop itself, what we check is, so x, y, and length. So x, y, and length. Our y is around, let's see, our y is 544, so it's 544 down. And our x, so the first time our x will be 0. Next time we're going to add I times 32. So in the first time it'll be 0 plus 32, then it'll be 0 plus 36, 0 plus 64, 0 plus 128, 0 plus 256, and it goes on like that until we reach the end of the screen. And if we're drawing the first tile, so if I is 0, the first tile, we're using the first one. For everything else, we're using the middle one. And for the last tile, we're using the last block. And these are just 3 different platforms. Now you might be questioning how we actually get these values. Well, one way is to manually do all the maths yourself and get these values. But for your ease, I've created a script. And this script will be available to you in the GitHub, and it's called Tile Editor. Basically, what this script does is it checks where you're clicking on, and it gives you this tuple, so this list that you can work with. Simply just run this program, and you'll get a grid like this, and go on to click. So I can create a platform right here. Let's create a platform. If you want to unselect, just click it again. So I'll create a platform like this, like so. And maybe I want some tiles over here as well. And I want some tiles over here. Maybe some tiles here. And let's jump around. So let's jump around to here. Maybe jump around to here and create some tiles over here. So maybe I want to create a tile sheet that looks like this. So you create it and then you click on close. And inside the console where it ran, it will give you the platforms you generated. So I made 1, 2, 3, 4, 5, 6, and 7 platforms. The first platform starts at 0, ends at 576, and it's 25 tiles long. The second platform starts here, ends here, it is this many tiles long, and so on and so forth. So I'll copy these, and inside my platforms, I'll just paste them in. I'll paste them in. So after this section, I'll add like a visual section where I'm explaining all of this by drawing it out. And you can look at that section and then make sure that you understand this portion of the video, because I know it can be a lot at the beginning and it can be a little bit complex, all the maths behind it and everything. If you're interested in learning it, then go ahead. If you're not, then all you need to understand is we're loading, we're scaling it, we have a list of platforms that you want to draw. Every tuple in this list represents one platform. It is the start, it is the end, and this is the number of tiles. And all this loop does is it goes through everything and draws it out on your screen. Just understand that much surfacially. Now, if you start it, the thing that we drew earlier, we get it perfectly in our tile format. Simple as that. All right, so far we have our game where we can jump around and we're colliding with the edges and the bottom, and we've created some platforms, right? but you want to be able to jump around these platforms and not just, like go through the platforms. So you need to add platform collisions. The way you do that is quite simple, but the logic for it can be a little bit complicated. So right now, all our platforms are a bunch of variables or a bunch of tuples. So these tuples aren't actually rectangles yet. We need to convert them into rectangles to be able to use them to check if we're hitting the player. So around over here, after we're checking all of our key games, we're going to do a loop. So we're going to create a list, platform rex, and it's an empty list for now. Basically, what I want to do is I want to convert all of these just raw values. So right now, these are just raw values where we're placing images, right? So I want to take these raw values and I want to draw rectangles. And based on those rectangles, I want to check if my player rectangle and those rectangles are colliding. Since I don't want to hard code anything, I will just take these values, these tuples, and I will create rectangles using those. So the logic is pretty simple, platform rex. And again, we take for x, y, and length. So these are three things that I have in platforms. So again, platforms looks like this. I have x, y, and width. I'll take those three things and I'll create a rectangle. So rect equals to pygame.rect x, y, and length times 32, because the length right now we have like 25 tiles. So if we have 25 tiles, the length is going to be 25 times 32, because one tile, so one of these tiles is 25 long. So if you have 25 tiles, actually one tile is 32 pixels long. So if you have 25 tiles, obviously it'll be 25 times 32 pixels long. So length is going to be 25 times 32, or whatever the length is. So if there's 7 tiles, then it's going to be 7 times 32 long. And the height is just going to be 32, because all of these rectangles, no matter how big the platform is, it's just 32, right? So we have, let's say, 25 tiles right here. So it's going to be 25 times 32. It's going to create a rectangle that is 25 times 32 long. And the width of all the rectangles are just going to be 32. And the starting and ending position is given right here. So we just use the starting and ending position right here. In the very end, so every rectangle that we create, platform rex.append rect. So now we have a list. What is in this list? Basically, every single rectangle that we're defining right here is now actually a rectangle that we can work with that exists in this list. So this is a list of all the platforms in rectangles. What this is doing is it's converting our platforms raw list into Pygame rectangles. Now we have rectangles, so we can actually check collision against those rectangles. Here is where I'd like to reorder a few things. Velocity should always be added at the very end. So the velocity variable that I have right here should be added at the very end. So I'm going to cut it and I will add it at the very end right here. Just make sure that this is at the very end, because we'll be moving our player a bunch and velocity should be added at the very end of that. Next, we're going to look at rect x and rect y. So looking at our player and these platforms, our player can collide with the platform two ways. Either the player collides with the bottom of the platform or the top of the platform, or the player collides with the left and the right of the platform. So we have 4 different collisions to check. At the very beginning, I want to check if the player is colliding to the left or the right of the platform. So for platform in platform rex, so we're getting all of the platforms that we have right now, and we're checking if player rect dot collide rect platform. So we're checking if the player is colliding with any platform that is currently on the map. So every single platform we have inside this list, and we're basically checking if our player is colliding with any of them. If our player is colliding with any of them, we're going to check a few more conditions. If the velocity of our player, vel x, is less than 0, so if the player is moving left while colliding with a rectangle, player rect dot right equals to platform dot left. So understand this line of code. This condition means that our player is moving towards the right. Our player is moving towards the right and it collided with a platform. So player rect dot right, that means the right side of our player should equal to the left side of the platform. If this player is moving towards the right and it collides with this platform, that means the left side of this platform should equal to the right side of this player. So the player shouldn't be able to move further than the left side of this platform. And that is basically the platform collision. As you can see, I was colliding with this rectangle and it updates. So my player cannot move further right because the right side of the player is locked to the left side of the platform. It's a bit glitchy now, but it will make sense. The other condition is if the player was moving left. That means if the player's velocity is less than 0. Then the left side of the player, so the left side of the player should equal to the right side of the platform. Simple as that. If the player is moving right, then we should hit the left of the platform. If the player is moving left, then we should hit the right side of the platform. It is pretty simple. Just pay more attention to it and I'm sure you'll get it. Next, we want to check for the Y collision, so the top and bottom. So for platform in platform rect, so we're going to get all of the platforms and we're going to check if player rect dot collide rect is colliding with a platform. So in both of these cases, we're checking if the player is colliding with a platform. In this case, we're checking specifically if it was colliding when moving left or right and set it so that we're not colliding inside the left or inside the right. In this case, we're going to be checking if it's colliding top or bottom. So if vel y is greater than 0, that means our player is currently falling. If our player is falling while colliding, then player rect.bottom equals to platform.top. So doing this basically means we were falling, right? That means our velocity y was greater than 0. We were falling down. When we're falling down, if the bottom of our player is colliding with the top of the platform, then we want to set the bottom to be equal to the top so that our player can no longer go through that platform. Also, right after doing this, you can see that it is glitching a little bit because it keeps trying to go under. To stop that from happening, we simply just set the value of velocity y to 0. That means the player will no longer fall. Once it has touched this platform, it will no longer try to go further down. So you can see it stops glitching. Also, right now, if you do this, our player cannot jump. I'm pressing space key right now, but I cannot jump. That is because our on ground, so this variable is false. We have to actually set it to true. On ground, set it to true. That means we're telling our game that we are currently on the ground and we should be able to jump. So now we should be able to jump right there. You can see that I cannot collide with the left of this because as soon as I collide with the left of the platform, the game checks if I'm colliding and it sets the right side to be equal to the left side. So it cannot go inside, right? I also feel like this jump speed is a bit less, the jump force, so I'll increase it. Let's set it to something like 12 for now. Okay, I can jump a bit higher. And you can see that the left side is colliding, the left side is colliding. Let's try to collide on the right side. The right side, oops, the right side should also be colliding. The reason why we're glitching and going through platforms is because currently we don't have collisions for the bottom of the platform. So we can simply just, go clip through the bottom of the platform like this, which is really not ideal in a game because it leads to glitches like these where you can just clip through the bottom of the platforms and it moves left and right. So for that, we're going to check if we're colliding in the bottom. So if velocity is greater than 0, that means we're falling. Similarly, we can check if velocity is less than 0. If velocity is less than 0, that means we're currently jumping. So player player rect.top equals to platform.bottom. So the top of the player should not exceed the bottom of the platform. And again, we'll set our velocity y to 0. We're not going to set on ground to true because just because the head of the player collided with the platform doesn't mean that we're standing on ground. So if we do that, now if we check this, we cannot go through the bottom. Our head collides with the bottom and we cannot no longer clip through these platforms anymore. And we've efficiently created a place where we can collide with platforms and we can move around. And of course, you can create your own custom platforms. So far in our game, if you run it, you can move around with your player pretty smooth. We might fix the player movement later. It's a bit janky because as soon as you leave it, the player stops moving mid-air. You might want to add some inertia where there's eventual decay. So like if I let go of A or W, it like gradually stops instead of instantly stopping. And our player moves pretty nice. Now there's only a few things we need to add. So like we need to add levels. In our level, we want enemies to be moving around, and then we want some coins. And if you collect enough coins, then you win the game. If you touch an enemy, then you lose the game. So in this section, let's start by adding enemies. So right after we load in our platform images, let's load in our enemy image. So we have a bunch of images for our enemies. Let me look through. I think around, not tile 24, I think around tile 24 of characters. Okay, we have a bat. Let's try using this bat as our enemy. Right, so right after loading our platform images and everything like so, let's loading in our enemies. I hope all of this is making sense. We're going to load in our enemy with enemy img variable pygame.image.load, and I believe it was assets, images, tiles, characters, and tile 24. Don't forget to convert alpha. And I want to resize this as we always do, pygame.transform.scale. Let's set it to enemy image and let's resize it to 40 by 40. Right, so far so good. Next, we have a list for our platforms. And similarly, I want to have a list for my enemies. So I'll have a list of enemies. Usually in your games or like in production games that we use Pygame in, you wouldn't do it like this. You would use object-oriented programming where you would create classes and instances of that object. But since I don't want to complicate you with all of that stuff, I'm doing it very simply, just using lists. But normally you would do this using objects. Okay, so enemies. Our enemy needs to have a few properties. So it needs to be a rectangle. It needs to be looking at a specific direction, and it needs to start at one point and end at one point. So for example, I want an enemy right here. It needs to start here and end here. So it just needs to move back and forth right here. I don't want it to move anywhere else. The enemy itself is a rectangle, and it might have a direction of movement, right? So if it's facing right, I can set its direction to 1. And if it's facing left, I can set its direction to -1 or something like that. So I want a single enemy to have multiple properties. So using a tuple wouldn't really make sense in this case. So I'll use a native Python type, which is a dictionary. So a dictionary can have multiple values. So let's set one enemy. Let's set the key rect to be just a pygame.rect. And we'll start it at 200. We will end it at 400. We'll set the x to 200 and we'll set the y to 400. Then we'll set its size to be 40, 40 because that's the size of our enemy image. Now, I'm sure you're familiar with dictionaries, but if you're not, basically understand it like a box. So it's a box where you can have multiple properties for every single thing that you create. Since we need our enemies to have multiple properties, like it needs to have a rectangle, facing direction, how far it's going to move, so I'm creating a dictionary. Speaking of that, right after rect, I'll set its direction. So let's set direction by default to be 1. So it's moving towards the right, maybe if it's 1. Then let's set a minimum x value. So the minimum value, the least amount to the left it can go. So let's set it to be around 100. And let's set a max x value. So max x value, let's set it to something like 300. So it's going to move about in 100 and 300. So it's going to start maybe at, so if it's 200, 400, so it's going to start around over here. And the minimum it's going to go is all the way to the left 100 right here, and the maximum is going to go to the right 300 right here. So it's going to move back and forth in this direction. And we've defined our enemy like so. Now we actually need to add the movement logic. Now the movement logic is always going to go inside the game loop itself. And we'll do this. So we can do this right at the top, right after we take all of our player inputs and right before our update section. So right before our update section, we can do something like enemy speed. So we want our enemy to have a speed, right? Like our player has a speed of 4, our enemy might need a speed 2. So for enemy in enemies, so we're pulling out that list and we're getting a dictionary. So when we do enemy, we get this. First of all, we get this one, and if we add a comma and then add in another enemy like so, like same, we can copy this and paste it. So we can add another enemy like so. Let's say instead of 200, 400, let's set it to 800 and 300. Let's set minimum x to be 700 and maximum x to be 900. Actually, 900 would go off the screen. So let's set this to be 700 instead, and let's set this to be 600, 800. Something like this. So the first time it'll pull out this enemy, and the second time it'll pull out this enemy. So every time we pull out an enemy, right here, every time we pull out an enemy, the first thing we need to do is enemy and get the rectangle. So rect will give us our pygame.rect, and which we can access the x value. So it gives us this pygame.rect and we can access its x value, right? So we need to check, we need to actually increase the x value by enemy speed times enemy direction. So if it's 1, then enemy speed is going to increase by 2. If the direction is negative, then our enemy speed is going to decrease by 2. Makes sense. Since we're multiplying by this variable, if it's positive, it'll go to the right. If it's negative, it'll go to the left. And after that, we need to check. So we need to check if we're out of bounds. So if enemy rect.x is, let's say, smaller than or equals to enemy minimum x. So we have a minimum x value, and if the rectangle has gone too far to the left, we want to reverse the direction, right? We want to reverse the direction. We actually want to set it to 1. So 1 means that now the enemy starts moving towards the right. This means if we go too far to the left, we want our enemy to start moving to the right. And we'll do the same thing, but this time, if rect x is greater than equals to the max value of x, so it's gone too far to the right, we want it to start moving left, because since we're multiplying by this variable right here, we're multiplying it by this. When we multiply the speed by negative, our x will start going towards the left. And that should be it. If we play it right now, you won't see your enemy. And can you tell me why that's the case? Well, because we haven't drawn our enemy on the screen yet. We have to do that in the draw section. So right here, we're drawing our player. So this is drawing our player. Let's say this is drawing our background. So remember, anything that you put at the last will be drawn on the very top. So if you draw our enemy before we draw our background, our enemy will be hidden. So first we draw the enemy, then we draw the player on top, and then we're drawing the platform on top, and let's draw our enemy on top of everything else. So enemy drawing. All we need to do is for enemy in enemies, we take every single enemy in enemies and we draw it. So screen.blit. We want to draw the PNG, so enemy img on enemy rect. So blit means we're taking that image and then we're drawing it on top of this rectangle. And if we play this file currently, as you can see, we get two bats. So this bat is moving left, and as soon as it notices that it's going too far left, it reverses its direction. If it's going too far right, it reverses the direction, and same for this. So it stays inbound for both of those bats. This bat is going too far to the right, so I might want to change that. Maximum is 800, so let's just set maximum to be 700. Let's draw it at 600, and let's do 500 for this. So you can play around with these values to draw your bat where you would like. Also, you likely don't want it to collide with your rectangles like this. So just play around with your enemies and just set them where you would like them to be. And then we can move on. So minimum, instead of setting to 500, let's set it to 600. And our enemy, okay, our bat is just moving left and right there. The next thing you want to do is you want to check if your player is colliding with the bat. If your player is colliding with a bat, then let's say you want to immediately over the game. So you just want to print out game over if you're colliding with the bat. And we'll do collisions in the next section. All right, so far we can start our game. And I've changed up the sprites of the platforms and then the enemies a little bit. You can go into the level editor, so like the tile editor file that I've made, and then create your own level like this. So you can move around like this, and this is a pretty fun one. You can jump on all the platforms. Some are a bit tricky, so you have to dodge this bat a little bit if you want to get here, and you have to dodge this bat as well, so you have to perfectly time it. And moving between platforms is pretty fun. Right. Now, all we need is the first thing we need is when we touch these enemies, currently nothing's happening. What I want to do is as soon as you touch an enemy, the game is over. So like you don't want to touch any enemies throughout this game. And there'll be coins throughout that you have to collect all the coins. And once you do all of that, then game is over and you win. So to do that, first of all, let's exit out of here. All I want to do is create a function or like create a functionality where if you touch an enemy, you stop playing the game. So like you cannot play the game anymore. So I'll create a variable called game state and let's set it to playing for now. So this is going to change playing, game over, or win, right? So three things. And we're going to check collision, basically just basic collision check. So right before I'm drawing the screen, I'm going to get for enemy in enemies. So I'm getting all of my enemies. And if player underscore rect dot collide rect enemy rect. So I think that's all I'm going to check because let's have a look at our enemies that I updated. So if you look at our enemies, then the enemy has a rectangle around it, and we can check for collision with this rectangle. We're basically saying if our player is colliding with our enemy, then I want to set the game state to game over. And that's all I'll do actually. And I will actually wrap this in another forced if statement. So if game state equals to playing. So if the game isn't playing, then we don't need to check this at all. It'll automatically be game over, right? I think, okay, so it's playing. If we're not playing, it's going to be game over anyway, so we don't need to check this. Now, what does game state equal to game over actually do? Well, I don't want everything to stop. I just want the player to not be able to move anymore. So I can create a if condition here. If game state equals to running. So if game is running, then I want my controls to work. If game state equals to anything else than running, then none of these will work, so my controls won't work anymore. Let's check that. So I think I touched the bat as soon as I started. So if I move around, actually running, it's not running. I think it's playing, that's why. So if I move around, I can move around perfectly, but I hit a bat right there and now I cannot move around anymore. So I can move around as long as I don't hit a bat, I can move around. So I hit a bat right there and now it's game over. So for basics of game over, that's all I'll do for now, and we'll add an ending screen and sound and music in it. All right, so far we can move around We can hit enemies, and as soon as we touch an enemy, it's game over. We cannot move around anymore. So the next thing we need to add is actually a score system where there are coins and you can collect the coins throughout the map. So inside our assets, let's look at images and let's look at if we have a coin looking like object. So we have keys, we have mushrooms, and okay, we do have gems. So tile 67 is a gem. Let's see if we can find anything else. Oh, we do have a coin. Okay, tile 0151 is a coin. So 0151 will be our coin. Let me just close everything else and go back to my main, tile 0151. So right after loading our enemies and loading our player platform and everything, let's load in our coin. So loading in our coin, which is coin img equals to pygame dot image dot load assets slash images slash tiles, and then tile 0151. So 0151 dot converted to alpha. Then enemy, no, actually coin img, we need to resize it, pygame dot transform dot scale coin img, and let's set its size to be a bit smaller, so maybe just 32 by 32, and that's our coin. Next, similarly to how we created platforms and how we created enemies, we're going to create coins. So coins equals to, it's going to be a list, and inside this list we're going to again create a dictionary. So the first value that we want in our dictionary is the rect, which is the rectangle that the coin is going to sit inside. So pygame.rect, and we can give in a few values. We can play around right here. So let me look at the platform. Let's place 1 at the start of every platform. So not every, but a few of the platforms. So let's go to x0, then y instead of 160, I'm going to reduce that by 32. So I'm going to place it at y 130. And it's going to be 24 by 24. And I'm going to set another property on it, which is collected. So if the coin isn't collected, then we don't want to display it. So by default, collected will be false. Let's just set up 1 coin for now, and I'll do the rest in my free time, and you can follow along as well. Next, we actually need a global score. So instead of, I'll just add a score variable, and I'll set it to 0 by default. Now, we need to check for collisions against coins. So similarly, how we check for collisions against, well, everything, we can check collision against coins right here. So we're going to loop through for coin in coins, every item inside coins, and if not coin collected, so if true, coin collected, if it's false, then this condition will be true. So if our coin has not been collected yet and player rect is colliding with that coin, so player rect collider rect is colliding with our coin. So what we're checking right here is if our coin is not collected. And if our player's rectangle is colliding with our coin's rectangle, then we want to set the coins collected to true first of all. So now that the coin is collected, this condition can never be ran again on the same coin, meaning one coin cannot be collected multiple times. And I want to increase my score by, let's say, 10. Lastly, I can have an if condition. So this is simply to collecting coin logic, and I can set another. So this would be win condition. Win condition can be if our score is greater than equals to the length of coins. Then game state, earlier we did game over, we can do game state win. Now, length of coins times 10 should be in place because we're increasing our score by 10. If you just increase your score by 1, then you don't need this times 10. Okay, that's all it is. And now finally, we should be able to play our game and collect coins. But if you start up right now, again, you cannot see the coins because we haven't actually drawn the coins in. And we'll do that while drawing on the screen. So at the very end, after drawing our enemy, let's say coin drawing to draw our coins. And this is also pretty simple. So for coin in coins, if not coin collected, so we don't want to draw coins that already have been collected. Any coins that haven't been collected get split onto the screen. So we get the coin image and draw it on the coin rectangle. And all of our coins should be on the screen. Well, there's just one coin at the very top right there. Let's try to get to the coin without dying. So I'm going to come right here. And once we get the coin disappears and our player stops moving. Because after the coin disappears, the game condition becomes win and it's not playing, so our player cannot move anymore. Since we had just one coin, as soon as we collect a single coin, the game ends immediately. So we can add multiple coins. Let's just add another coin. Let's see here, where can I add another one? I can add another one at the edge of the screen, or I can add one at the bottom of the screen. Let's try to add one at the bottom. So instead of 130, let's see what the bottom platform would look like. Let's set it to 500. And okay, there's a coin right here. Now, if I just collect the coin at the top right here, our game shouldn't end. See, I can still move around, but as soon as I collect the last coin, the game ends and I cannot move around anymore. Well, we cannot really see our score right now, so I should add a way that you can see your score. So to add variables to your screen, so like to add text to your screen, the first thing that you need to do in Pygame is create a font. So font is basically a Pygame object, so pygame.font.font, and you set none and 26. So none basically means you use the default font and you're not using a font file, or you can add a font file if you want to use a custom font, and 26 is basically the size. So you're just creating a font. And in your draw section, right after drawing your coins, let's draw in our score. So we're going to set score text equals to font.render. So we're rendering using a font, and we're going to create an f string. So coins is the score that we have, divided by length. Let's divide it by the length of coins. That is our score. Let's set it to true. True means let's not look into that. And let's set a color. So color might be 255, 220, and 0. Again, an RGB color. And after we've defined our score text, let's split it onto our screen. So let's show it onto our screen. We're going to show score text, and we're going to show it at 10, 10. So we created a font at the very top. We defined a score text, and in our score text, we have this text. Then we have anti-alias true, and we have a color. Right after that, we blit it onto the screen like so. So let's see how that looks like in our game. You can see we get coins 0 out of 2. Now, if I go ahead right over here and I collect this coin, I get coins 10 out of 2. That is a mistake because on the score on top right here, I'm multiplying it by 10, whereas I should just multiply it by 1. So I'll find where I'm multiplying by 10. So right here, I'm increasing the score by 10. So let's just increase the score by 1 instead of 10. And let's play that game again. And this time, I'll move around. I'll collect this coin, and now I get coins 1 out of 2. When I get 2 out of 2, the game ends. I cannot move anymore, but everything else still works. Right, so we have added coin logic and we have added score logic. Okay, now that we're done with that, I actually changed the background color to instead of a dark gray, I changed it to a light blue because I think that looks better. So if you open up our game right now, this is what it looks like. Our player can look left and right. It can jump, and once it's jumping, it can collect coins. Once we collect coins, you win, and you can restart the game. So if you press R while mid-game, you cannot restart it, and you have to collect all of the coins. You can play around with the levels, you can play around with where you place your coins and all, but this section I'm going to be talking about sound effects, and this will be our second last section, and in the final section we will package the game into a nice exe that you can ship. So at the very top of your game, you need to initialize some audio assets. So for audio, the first thing that you need to do, so like we did pygame.init, we need to do something called pygame.mixer.init. This lets us use sound features inside our game. And we can load a bunch of different music. So pygame.mixer.music.load, and let's load in one of our assets. So assets slash music slash background music dot WAV. And after we've imported this, then you can set the volume. So to set the volume, just do pygame.mixer.music.setVolume. And let's set it to 0.4, just 40%. I don't want it to be very loud. Then pygame.mixer.music.play -1. So this -1 basically means that you start playing this music and you just loop forever. So if I start the game, you should start playing the music and it will loop on forever. And it stops when you click exit, obviously. Next, you want to load in sound effects. So this audio is for background music. You can also add sound effects. So for sound effects, you simply just load in your effects. So I have an effect for jump. So jump sound effect equals to pygame.mixer.sound. And I will load in assets, music, not music, I think it's under sounds. And I will load in the jump.wav. And jump sfx.setVolume. I'm also going to set this to 0.4. I'm going to copy this down, and instead of jump, I have a coin sfx. So a sound effect that plays when I collect a coin. So coin sfx. And instead of jump, I believe it is just coin. So I'll delete this and I'll just do coin. But they don't play right off the bat. They need to only play when you're jumping and when you're collecting a coin. So you can change the sound effect of this volume. So I'll just set it to a bit higher than the background music. And all you need to do to play the sound is call this function. So wherever we're jumping, so I believe we were jumping somewhere over here. So this is where we're jumping. So as soon as we jump, I want to play this sound. So to play it, I just do jump sfx.play. Simple as that. And when we're collecting a coin, so I believe we're collecting a coin right here, I just want to do coin sfx.play. And I'll just play through the game and see if this works. Actually, another thing that I want to do is if the game ends and we're resetting the game, I want to restart the music track. So I'll just do pygame.mixer.music.play -1. So all this does is if we're in the middle of the track, it doesn't continue, it stops it right there and starts it from the beginning. So let's test it. You get the jumping sound, and if you collect, you should get the coin sound. You do get the collecting sound, but it's slightly low, so I might want to increase this to 0.9, and I want to decrease the background music further to 0.2. So you can play around depending on the music you added. And there you go. So I might want to decrease the jump SFX a little bit. And I want to boost the volume to around 2. There you go. And you can add music effects if you're hitting an enemy. And you can add music effects if you're hitting an enemy. You can add music effects when you die, when you reset your game, so on and so forth. And with that final section, we've completed this entire platformer game. Although in this video, we did not really go into depth about object-oriented programming or about animations on our sprites, I believe we made a pretty fun game, and this is a solid foundation to create other platformer games in Python. What you can try next is to create different levels. You can add more enemies, you can add more functionalities to your player, so like maybe shooting mechanics. And if you're interested in more Pygame content and you want to see a different game made or like a specific thing that you want to make using Pygame, please let me know in the description. All of the source code will be in the description. And I'll see you in the next section where we package all of this into a nice exe file that you can send to your friends, your colleagues, and run off the bat. Over the starting screen for winning and for game over. So simply just scroll all the way to the bottom right here, and right before you flip your display, I'll add this text. So at the very top, before we do that, we have to define some other fonts. So we want a big font where pygame.font.font. We set it to none, but we set the size to something bigger, like 72. And we'll have another with the size of 42 and name it medium font. And after you do that, I just copy pasted this block of code, and this block of code, let's go line by line. It says if game state equals to win, then we create a new window, which is an overlay, and we set the color of that window. We blit it onto our current screen at 0, 0. Top of our screen, we draw this window, and there's a message that says you win, and there's another message that says press R to restart. And we have these two things drawn on the screen. So if we play it right now, and we collect both of these coins, if I can successfully do so, I collect one coin, and I collect the other coin, it says you win, press R to restart. And I have a small overlay that is like slightly blackish overlay. And if I press R, well, nothing happens because we haven't added that functionality, but nothing in the background is moving, and this looks pretty nice. Similarly, for losing the game, I added another overlay. So if game state is game over, then it says game over and press R to restart. And this happens every time you touch an enemy. So if you touch an enemy, it's the same thing, but it says game over and press R to restart. So the game start and game end features are right there. At the very end, I want to add a function that actually restarts our game. So I'll create a function called reset game. I'm sure you're familiar with functions, but function is just a block of code that you can call by yourself. And inside reset game, I'm going to set some variables. So I'm going to get player rect. I'm going to get vel x. I'm going to get vel y. I need the on ground. I need my score. I need the current game state. And I also need facing right variable. So all that global does is that all of these variables, I'm not creating new ones. I just want to use ones that already exist in this file. That's all it's saying. Just copy along if you don't understand this. The first thing I want to do is player rect. I want to create a new rectangle, so pygame.rect at 100, 400, 40, and 60. Then I want to set the velocity x to 0. I want to set the velocity y to 0, so I don't want it moving anymore. I set on ground to false. Basically, all I'm doing is resetting all of the variables for the player. So I'm setting the score to 0. Game state gets replaced to playing again. My facing right is by default whatever it was, so it goes to false again. And for coin in coins, I need to reset all of the coins since some would be collected, some may not be collected. So I'll set them to coin collected equals to false. So all of the coins aren't collected anymore. So every single coin isn't collected. Right after I do this, I actually want to double check if this is my actual player. So I'll Control F this. And when I created the player at the very beginning, I created the player at 100, 400 with 40, 40. So I have to create it with, in my function, with 100, 400, 40. It's not supposed to be 60, it's supposed to be 40. And it's simple as that. Now, at the very end, not at the very end, at the very top, outside this if scope, by the way, because we want this piece of code to run no matter what, if event.type equals to pygame dot, actually not right here. We need to remove this. Let's check it at the very top right here. If event is quit, then quit the game. If event.type equals to pygame dot key down. So that means we pressed on a key. And if event dot key, so if this key is equals to pygame dot key underscore r, so if it's the r key and the game state is not equals to playing, the game either has to be game over or the game win. If either of those are true, then we can call reset game. So you cannot reset the game mid-play. So like while playing, you cannot reset the game. You can only reset the game if it is anything else than playing. If you press the R key, it is going to reset your game, which is basically calling this function that respawns your player, stops it from moving, sets on ground to false, resets your score, resets your game state, makes you look wherever you were looking originally, and then makes all of the coins visible again. So let's try this. Let's try deliberately hitting an enemy. And once I do that, if I press R, then the game gets restarted. Let's try winning the game and restarting it. So collect a coin, collect another coin, you win, and you can press R to restart. You can see the coins get reset and our player gets spawned right back in. Creating the game, and you can go ahead and set your custom platforms, your enemies, your coins, and everything. And I've actually given you the tile sheet as well. So this tile editor, you can use this tile editor to, like, if you suppose you want to place a coin right here, you can see the positions where you want to place a coin by simply doing this, and it'll give you those positions where you need those coins. So it's pretty simple. You can do the same for enemies. You can try putting different enemies and such. But after you're completely done, well, one last thing that I want to leave you with is how to actually package your file. Sometimes your friends or like whoever you want to share this game to might not have Python installed on their device. Well, in that case, you can give them an exe file and they'll be able to run that exe file and play your game. So all you need to do is, first of all, pip install PyInstaller. So this is a package that we'll use to build your main file. Since I already have it installed, it shows requirements already satisfied. Otherwise, it will show that installing PyInstaller. Then you want to run PyInstaller --1 file. So it'll create one exe file. And you want to set the game to windowed mode. You don't want to set it to full screen because we're just checking for a cross button. And you want to give your file name, so main.py. After you give main.py, then it will start creating your main build file for you. And it should be done pretty soon. It depends on the speed of your CPU. And after it has completed, then it'll show you that the results are available in the Pygame tutorial list. So wherever you've stored it, it'll show it right there. So mine is right here. And if I go into the dist folder, I can see a main.exe file. Well, I can open this and play my game, but you'll notice that as soon as you open it, it gives you an unhandled exception in script saying that the assets, no file in assets. So that is because you don't actually have access to your assets folder. So one last thing that you need to do, so the assets folder that you had in your main root folder, so it cannot find that. If you simply just pull in your assets folder from your project root and drop it in here, once you open this game, you can play your game fully.